And we are live, folks. Thanks for tuning in. No screwing around today because we are running late. So we're looking at the sun at 171 angstroms. We're going to show you the normal data that we normally show you. But before we do that, two other things to cover. First of all, we are returning to the Peloton. I'm returning to the Peloton, your host, smAsho, aka Daniel Nigro, bike racer, already a public figure. So look in the links below if you'd like to sponsor the 2019 cycling campaign. We're raising $5,500 by May 1st. I do have a birthday coming up this month too, folks, so if you want to send me a present, it's April 18th. We're not posting that anyplace, so if you heard it here, you heard it here. Also, if you're interested in cycling, head to theveloshop.net. First thing we're going to cover is this Veritas video. Now, Veritasium video. Now, I watch the Veritasium channel, and it's a good guy. I'm not here to discount Veritasium. Veritasium is going to explain a small portion of the standard cosmological model of how a black hole works. What you see here on the right are beams of light coming in. This is light in his diagram. And I just note that the light is not bending. Space-time is bending, according to standard cosmology, and the light is traveling in a straight path. Anybody who's taken an astronomy class would have learned this. Let me pause the music for 1 minute and let him explain part of this.
So in order for you to get a parallel ray, which does not end up in the black hole, you actually have to go out 2.6 radii away.
He's talking about the Schwarzschild radii, which is the radius of the event horizon. Now, the most interesting part about this video is right here, where he's talking about viewing black holes from different angles. Now,
something that looks like that.
We see massive radio sources at the cores of all active galactic nuclei. Call them quasars, call them whatever you want, but they're massive radio sources. And so the real question is, when we look at a black hole from a different perspective, do we ever see a distorted perspective like what he's showing you here?
Why do we see
I just want
ring of light
show you an actual photo here.
This is what we could see if we were very close to the black hole. Something that looks truly spectacular.
He's talking about viewing it from this sort of an angle. You should see this sort of a distortion. In other words, you're not seeing a torus. You're seeing this totally distorted lensing of space caused by the distortion of gravity. However, when we actually look at certain things, now we're not talking about X3 here. We're talking about Cygnus X1, which we just did recently cover this also, as this is a brand new story also. Now, Cygnus A is the largest radio source in the entire sky, second only to the sun. Obviously, the sun is hitting us with stronger radio waves than Cygnus A, but this galaxy is believed to be somewhere in the realm of 5 to 650 million light years away. And so the thought is that this is what we're looking at. When you look at it from this view, you don't see the kind of lensing that he's talking about. You see these two inner jets, which are the torus viewed from the side. So what you're seeing is you're seeing this high density region and this high density region. And you're not seeing what Veritasium is showing with this diagram. Now, there are a lot of galaxies to look at, so perhaps we will see this, but the running theory with people like me is that we won't. So thanks, Veritasium. If you're not familiar with this channel, check it out. It's a good channel, doing lots of good science videos.
A question I get asked surprisingly often is Veritasium a real element? Nope. I made it up.
So anyway, he's a good guy. Check out the channel if you like. Veritasium. an element of truth. So here we are back at 171 angstroms. We're going to switch to 304 angstroms here as we see some filaments, and we want to see what we want to get an idea of what they may do. So back to the music. Now we did notice on stereo A that there's a big filament on the opposite side of the sun there. And let me just show you one more view here to give you the sunspot analysis. This sunspot could re-upgrade today because we do see some umbral activity forming behind it. So here's the colored magnetogram view. And back in this area, not that area, back in this area, there appears to be some umbra possibly forming. So you can keep an eye on that throughout the day. It may be upgraded to a beta class, but still not particularly strong and not particularly capable of producing major flares. Not likely to produce major flares. Now here's the view I was talking about before. I was looking at stereo A real quick, and there is a big prominence there on the opposite side of the sun, and that couldn't be any farther from being Earth-facing, folks. Next, we'll look at the real-time solar wind here. So we see a slightly negative Z, and the BT is looked like it dropped down a little bit there. It's down at 3.3 or so now. Phi angle is at 350. Solar wind density 3.16 protons per cubic centimeter. So that's a downtick from yesterday. And solar wind speed 412. So pretty low levels of activity there, folks. Here's the gong too. There's the last frame. And we see we are just about to make a crossing here, assuming nothing changes with this field. Let me play this for you so you can see the animation of the magnetic environment. You see undulations of the North Pole associated green colored portion on both sides there. And this is an indication of the increasing field strength of the solar polar North Pole, which is a good sign. Not a sign of a deepening solar minimum, but perhaps cycle 25 will be similar to cycle 24. Many folks were worried we were not going to get a cycle 25, and this is all good news. Again, there's the last frame. This hour is 2 hours and 2 minutes old, and we should be making this crossing today into the other pole-oriented portion of the current sheet. Now, it's not the right one either. There we go. That's the one we use. We're going to be looking at the magnetometers in a moment. Let's see if they've been fixed up. But first, let's look at spaceweather.com to note that the 10.7 centimeter radial flux is back up to 79. So that's a good thing. And I don't know what that's supposed to be. That's the predictions of the solar minimum. So, read the article. What can I say? We got to get through the report, folks, because we are running late, as I said. Anyway, visit the links below the video in the description. See the rest of our links. We did have a B-class flare. It's like about a B5 or a B6 there. And that was midday yesterday. Since then, it's been a little calmer. All right, so the KP index page is scrolling by itself, folks. I apologize for the technical difficulties, not caused by me. All right, so here's the magnetometer, and it looks like the GOES 15 has come back out of La La Land. It's not showing over 200 nanotesla anymore. And the GOES 14 is looking pretty normal. So let's hope this stays like it is. And yeah, if you see big perturbations in this today, that's the crossing of the current sheet, although it doesn't look like it's going to be a violent crossing to me. We do have a bit of a coronal hole wind stream happening which is responsible for a slight dip in the electron flux here. Nothing to write home about. Charging hazards are pretty much non-existent, a little bit in Northern South America and Central America and Mexico, but no big deal. F2 ionosphere layer looking totally normal. There's your auroral forecast. Let's move on to the planetary locations. Here's where they are now. Here's where they'll be at full moon in 1 week. Full moon in 1 week, folks. Here's solar hams analysis of the sunspot region, 2738. And as I stated, we do see some umbral cores forming here, possibly. I think that is an umbral core. So depending on its polarity, which it is going to be south pole polarity, if that's the only umbra that forms, that's not going to be upgraded to a beta class sunspot. We need some opposite polarity sunspots to form in order for this to upgrade to a beta class sunspot. Next, we'll look at the magnetosphere movies. And here's a good opportunity to show the example of a low density solar wind. We'll ignore the velocity today. Here's the density. You're going to see a lower density solar wind coming in from the left. That's the light color. The dark color is representative of high density plasma. And here's the pressure at quite low levels right now. We'll let the movie play through. So we got pretty low pressure, and the magnetosphere is in a receiving charge sort of a formation right now. Let's look at the ground magnetic perturbations here, as we do most days. First, we'll look at the poles. This data provided by University of Michigan, and for that, we thank you. Here's the global magnetic perturbations. Changes in the delta B field. Delta B, that is, changes in the B field. For you pole shift folks, we've got one over Canada. We've got one over Siberia. And the South Pole is migrating toward Eastern India, Western Australia, etc. And next, we're going to look at the Enlil prediction here on the Space Weather Enthusiast dashboard. So not a lot going on there, although they are predicting an uptick in the plasma density on the 16th. And I'm not sure why they're predicting that. There were some radio outbursts this morning, and we're not going to get into the weeds on that either. Anyway, there's the Enlil forecast. And let's move on. Look at the total electron content. This shows new viewers. If you're not aware, this shows things like GPS errors. So the denser the color here, the denser the electron content, the greater the GPS error. And it looks like we're going to have some significant ones in North America today, actually. So we'll have a few meters, a couple to a few meters of GPS errors. But the electron content forecast isn't very high. So let's move on here to earthquakes. And for some reason, this isn't the right setup at all. Let's refresh that. Not always the most cooperative site, folks. But we'll get through it. So let's look at the last 24 hours here. We see a 4.4 in Alaska. We see a 5.0 in Peru. Let's zoom that out. There's a 4.9 in Japan. Looks like a little swarm of activity there. 5.1 in Papua New Guinea. Probably not a tsunami generated from that, as it's not very big. Although we see a magnitude 4 on the list now. Anyway, no tsunami warning, advisory, watch, or threat. So quite a bit of activity at Papua New Guinea there. Oh, hey, that improves things, doesn't it? All right. Oh, yes, that's so much better. Thank goodness. All right, so here's a 4.8 at Papua New Guinea also. Here's a 5.0 at the southwest Indian Ridge there in the Indian Ocean. 4.6 in Indonesia. 5.0 at the Mid-Atlantic Ridge. Quite far south. 4.6 Central America there in Panama. 4.6 at over 600 kilometers depth at Fiji. 5.0 at Japan. 4.8 at the Philippines. 4.9 at Japan. 4.6 at Japan. So quite a swarm there. And that last one was at depth, 542 kilometers. So I would be looking for low pressure systems. In fact, I think I'll do it right now. Especially if I lived in Japan. Looking like the biggest hot spot of anybody right now. Let's just do a quick look at the pressure at Fiji and Japan, where the deep earthquakes happened, to see if there's any anomalous low pressure threat especially. And there we see a pretty strong low just east of New Zealand. And we see some pretty anomalous looking systems here too, folks. Check out the airflow there. That is abnormal to say the least. This area needs to stay on earthquake alert. Let's look at the 9,000 meter winds here. And we do see a couple percolations here in the upper atmosphere. We see the jet stream doing some odd things. At least not going east to west. So that area also, some pretty anomalous looking systems there. And a big convergence zone right in this region. Let's look at the U.S. There's that massive low over, it's now over South Dakota. And here's your U.S. Doppler radar map. Massive convergence line going all the way from the Gulf of Mexico to Canada. We got big snow still falling in North Dakota, South Dakota, Michigan. I'm sorry, Minnesota and Wisconsin. And northern Michigan is getting iced. Let's hope no power outages out there. They got a power line on the photo. Americans across the central U.S. were advised to remain in their homes for a second day in a row Thursday as a monster winter-like storm continues to sweep the region. That's what we call kaplastered, folks. Let's give you a water vapor map here for those of you who are waiting for this stuff to pass. Incidentally, we are almost done with the video, folks. Bear with us one moment. This is going to be a pretty short installment, as we are already out of music. Anyway, there's your U.S. water vapor map, complete with a spaceship flying in front of the satellite. You can see the spaceship right here. I'm not sure if it's one of those Borg cubes or perhaps it's from a different fictional thing. Anyway, there's your water vapor map. We see this this band of dry air creating a massive pressure gradient there with all that wet air over the central U.S. right in this region. There's your wet air. There's your dry air. And they are smashing together. They're not mashing together. They're just smashing together. And so when in doubt, when you're wondering when the snow or rain is going to change or whatever's going to happen, and you can't tell from the Doppler radar, look at a water vapor map. If you understand what's on the map, you'll be able to predict the weather and impress your friends. So please do. Let's look at volcanoes for today, April 12th. Kluchevskoy producing a 17,000-foot plume there, so that's back on the list. Karimsky back on the list, producing a 10,000-foot plume there. Shivaluch remaining on the list with a 34,000-foot plume. And since we looked at it yesterday, let's go back and see if we can see the sulfur dioxide cloud. Should be on the map. And where are my layers? That's odd. There we go. Sulfur dioxide is what you want. Head over to the Kamchatka Peninsula. We didn't see any sulfur dioxide yesterday when we looked. And today, I actually remember where it is, folks. Well, maybe it's producing ash and there's no sulfur coming out of it. I find that a little bit extraordinary, but there's the volcano. I don't see any sulfur. So sulfur dioxide mass, also available on windy.com. Yes, a lot of data there. If you're into that kind of stuff, check it out. We put up this paper yesterday. Not that. Put up this paper on andrewcollins.com about Cygnus X3 and the cosmic ray question. If you're not familiar with this article, please read it. It's super interesting. And if you're not familiar with Cygnus X3, it's the most distant single object visible to the naked eye. It's the tail of the swan in the constellation Cygnus, the tail of the swan known as the star Deneb, which also at the other end of the precessional cycle is our celestial North Pole. So if you don't think it's important, guess again. The pyramids and Göbekli Tepe seem to be oriented to this star. Anyway, here's some more images of Cygnus A, which is what we were looking at from the side. And I would note that the black hole image that's all over the news is being viewed from a perpendicular angle. It's being viewed from an angle like this, down the jet. And that's why the zoom in, it looks like you're traveling down the jet. The good thing about Cygnus A is that we're looking at it from the side. You are in this thing's B field. So the B field that comes out of this is going to be this kind of a thing. And when we look at this, the same way we looked at Sagittarius A star and M87, we're probably not going to see the kind of lensing that Veritas was talking about. Veritasium, not to be confused with James O'Keefe. All right, anyway, if you want to look at transients, we'll leave links to this in the description. This is how we monitor things. So for instance, if you want to see what M87 is doing in terms of radio emissions, just click Find. Type in the object you're looking for. There's M87. You click on it. And there are the fast radio bursts from the Swift Bat Burst Alert Telescope. And we actually do see something interesting here, the same way we've been seeing with X3. And I'm actually going to look at it for a minute here. Here are these are day of 2019. I don't know why they annotate it this way. Some kind of old Ptolemaic calendar system or something. But you see the transients, they're all over the place. And then all of a sudden, they're kind of right in the middle. What's up with that? Is that a quantum effect because everybody's staring at it right now? All right. Anyway, just being facetious, folks. And let's also look at X3, as this has been showing some odd behavior. Cygnus X3 always goes into a low activity state before it produces a massive burst. As you can see from over here, historically, from 2005 to through the current time, there's the timeline. Here's the daily bursts. Now keep in mind, Cygnus X3 is one of the most reliable sources of cosmic rays in the entire universe, if not the most reliable source. This thing is getting physical objects all the way to the Earth. And what's so significant about it? Well, what's so significant about it is we're viewing this blazar, as it's called, from this direction, right down the jet. Does that mean it's some sort of progenitor of the solar system or the sun? Does it mean that it has to do with the sun's path through the galaxy? Well, some of us are trying to figure that out. And so we're looking right down the jet of this. And we're going to be interested in some interesting astronomy coming out. Now, the difference here is obviously this is a galactic core. This is a galaxy here. And when you view this through visible, it just looks like a big sphere. And so obviously there's a lot more massive than Cygnus X3. But we're waiting for some good science to come out, folks. And anyway, check out the current situation of what X3's been doing. See the way it's flatlined there? It's not doing that on any other part of the graph. So we're watching this. I'm watching this every day because the outbursts from this have direct effects on the Northern Hemisphere, believe it or not. All right, so anyway, check out our links in the description. There is a GoFundMe. There you can send us one-time donations through PayPal, and there is a Patreon, which we are going to be setting up sometime soon. Let's show you the rest of the data here. As we've amassed a little bit more, I'll show you the intensity gram here. And then I'll open up the chat to see who is hanging. By the way, thanks everybody for tuning in. I appreciate it. There's a stream. So there you can see that umbra that's trailing Sunspot 2738. If I had to guess, I would say the whole system's breaking down. And let's look at the 193 angstrom view. Thank you for joining us, everybody. Thank you for your hard work, smAsho staff. Welcome, Mary and Terrence and Syrianification and Southern California Deplorable and Chris Meyer. Thanks for joining us, everybody. We are out of here in a moment. You zoom this out a little bit. I would also note that the North Pole coronal hole still appears to be shrinking a bit. Probably a sign of a North Pole field flip coming on. And that's what we want. Thank you, Chris Meyer. Thanks, everybody, for commenting. Not BB guns, airsoft guns. Plastic 6mm, 0.2 gram projectiles. All right, thanks again for tuning in, everybody, folks. Please visit the links in the description, as there's a lot of other stuff and a lot of other reading to do. So, Korograd Grogo. I don't remember back in the 60s because I was born in 1976. Aliens were doing all the probing. They finally watch it looking for them. I don't know. Human butts. Yeah, I don't know. Yes, I remember. All right, thanks again, folks. We are out of here. Remember, when you're staring at the sun, don't drink, and if you drink, don't drive. May the solar wind be at your back and the atherosclerosis absent from your arteries.